So today we're going to look at using stars to really solve rational number word problems. If you're paying attention in class, you know that Ms. Lawson gave a chart on this earlier in the year. But if you don't actually find it in your book bag, you can see it as a chart in a room. It's a very simple acronym. STARS, just standing for search, translate, answer, and reread. But it's more than that. It's more than just thinking about these 4 words. When I'm searching a problem, I'm really thinking, what do I know? And what do I need to know? From that problem. So I'm really searching for those details as I'm going through the problem and really figuring out what's important there and what do I really need to figure out. When I'm translating, you're taking those words and you're now starting to translate it into something mathematical. So actually trying to figure out, can I translate it into an equation or some type of expression? Sometimes for kids this means putting it into a visual, but we want to make sure we're translating all these words into math and making sure we really understand the problem. Then we're actually going to calculate to find our solution. What's our answer, our solution? Using some type of math we've learned. And then when we reread, we're really also reflecting and thinking, does this make sense? Does my answer really make sense? And that's something that a lot of times we're so tired from just figuring out the problem that we don't really go back and really think, does this make any sense? And we're likely to make little errors like a decimal error or just some type of small computational error that we probably would have caught if we would have just paid attention a little more to what we were doing in our work and how it relates to the answer. So what we're going to do is we're going to use this exact strategy to play with 2 specific questions. So the first question we're going to look at is question 27. 2 bags of concrete mixed together have the same weight. Together they weigh 40.6 pounds. To make them lighter, 10.5 pounds of concrete mixture was removed from each bag. What is the final weight in each bag? So remember, our first step is to really search the problem. And just by looking at it, I already noticed, I have 2 numbers, they stand right out at me, one being a decimal and one being a fraction. I actually did that on purpose since we're working so hard on rational numbers. So what are we doing? We know there are 2 bags. I know that together they weigh 40.6 pounds. And I know if I want to make it lighter, 10.5 pounds was removed. So I'm thinking lighter, I'm thinking removed, or taking something away from there. And finally, we want to figure out what is the final weight. That's what I want to know. So what do I know? I know how much both bags weigh. I know that I'm taking out some of the weight, some of the concrete, that's going to make it lighter. And I know I'm trying to figure out what the actual bag is going to weigh at the end. So using that, we're ready to start translating. And like I said, I think very visually sometimes when I translate. So I know that my 2 bags together weigh 40.6 pounds. And I know I'm going to take out, I'm going to remove 10.5 pounds. And then I'll have a new weight. Okay? If sometimes I always think of it as a bar model too. I know in the beginning I had 40.6. I'm going to take out a piece of it, 10.5, and I really want to know what piece is left. Okay, that's making me think of a subtraction problem because I'm taking out a part and I want to figure out what's left. So my equation must be, what is 40.6 minus 10.5 is going to give me X. So just by looking at this problem, I can tell something off the bat. My 2 numbers are not the same. One's a fraction, one's really a decimal, so we need to do something about that. I actually like working with decimals a little bit more than fractions. You may be different, but you need to make a decision. Do I want both to be fractions or do I want both to be decimals? If I change this to a fraction, 6/10, I'm going to have to change the denominators and then subtract. So I'm going to decide instead to just change this into a decimal because this is a benchmark and I know that 10.5 is a very easy decimal number. But if you don't remember, you can just take the half and turn it into a division problem. 1 over 2, 1 divided by 2. 1 is being divided by 2. And I can get 0.5. But at this point, I already knew that because it was a mental math problem. If you're not sure, you can just pause it from here and actually check my math to see if it's correct. Okay? So we're moving on. So I'm going to rewrite it as 40.6 minus 10.5 equals x. And that's something I can definitely solve. Let's stack it just so I can see it. And I know I have 1/10 and 30. So I have 30.1 pounds. All right, let's think, does my answer actually make sense? So I'm going to do just some estimating. So I had about 40 pounds and I removed about 10, so my answer should be about 30. So right there, I know that my answer is very, very close. And looking at my work and just double checking it to make sure, 40.6 minus 10.5, my decimals are aligned together and I have something in every place, so I can simply subtract 1, 0, 3. Yep, so my answer absolutely makes sense using my stars chart. So that's good on the first one. So let's look at the second problem. Again, I went through all my different steps: search, translate, answer, and reread. And we're going to look at question 22 here. Lena ran a total of 7 miles around her school track. Each lap around the track is 4/5 of a mile. How many laps did Lena run? Okay, so let's search through the problem. What do we know? We know that she ran a total of 7 miles. That's always good to know, my total. And we know that each lap was 4.5. So every time she ran around, it was only 4/5 of a mile. And I want to know how many laps did she run around? So how many times of her running around this track does she need to do to get to 7 miles? Okay, so I searched through and I have what we need to know. So let's start translating it. So I have a track. If she goes around the whole track once, it's 4/5. And she's going to keep going around it and around it until she gets to 7 miles. So I'm really taking my 7 miles, which is my total, and I'm trying to figure out how many 4/5 can I break this up into. That's really my question. I'm chopping up. How many 4/5 are going to make 7 miles? That reminds me, if I'm taking something and I'm evenly sharing it out, they're all going to be 4/5. That's a division problem. So I'm really doing 7 divided by 4/5, and there's my unknown, there's my x. That's how I translate it out. We started looking at division and fractions, and so many of us are really strong at it, so I know I'm going to take my first number and keep it 7. I am going to put it over 1, so it does turn into a fraction. Keep, change, flip. Oh, it's like ketchup, mustard, relish. So I'm going to keep this one, ketchup. Mustard, I'm going to change this to multiplication, and relish, I'm going to find a reciprocal. I'm going to flip this around. Okay, so that was my keep. I kept the first one, I multiplied, and I found the reciprocal. I kept this, I turned this to multiplication, I found the reciprocal. And now I can just multiply. 7 times 5 is 35.
I'm 13,
1
12.
times
You're 11.
4 is 4. And I never keep my answers that way, so we're going to have to change it back to a mixed number. 35 divided by 4. I know 4 can go into 35 8 times over a remainder of 3. Because my answer, my whole question was in fractions, I can keep my answer in fractional form. So my answer is 8, and my remainder 4 thirds. That's how many times he had to run around the track. Does that make sense? Well, it kind of does to me, because when I look back at the problem, every single time around it isn't a whole lap. So even if he went around 7 times, because each one is less than a mile each time, he's not going to have enough. But I'm going to need a little bit more because it's definitely close to having 1 hole. So it makes sense to me that my number would be a little bit more, around 8. And that's basically how I use my starch cut to make sure that not only can I solve a problem correctly, but I can also find a solution and reflect on my work to see if it makes sense. Use this method tomorrow when you're working on your word problem.